soaking ourselves in the boundlessness of the universe we individuals have, reliably examine the opportunity of whether we genuinely are the primary species to have a planet, checking the stars out, contemplating distant universes, and researching the potential forever past our little blue planet. That potential has finally seen NASA's boss has just announced that the James Webb Space Telescope has discovered something extraordinary at the edge of our limitless neighborhood. The James Webb Telescope has zeroed in on Proxima B, the close by, however, perhaps legitimate exoplanet to Earth. We review that a potential city made by sharp life had been perceived, which to date we don't have even the remotest clue about. The new James Webb revelation shows how the brightness of the fake lights of the city of Proxima B has extended. Also, the engineered arrangement of the air of this exoplanet has been viewed as by NASA's boss. The JWST may have used all its innovation effectively and has distinguished life on Proxima B planet, tracked down 4.14 light a long time from our planetary gathering. Proxima B has turned into an idiosyncrasy of reputation on the grounds that of being viable. This genuine potential exoplanet circles its parent star, Proximus, under a red bantam that is a lot more modest and cooler than our sun. Viewed as in 2016, Proxima B lies in the star's valid zone, otherwise called the Goldilocks zone, which is the area around the star where conditions could allow the presence of fluid water, a vital component for life. As far as we might be concerned, Proxima B's closeness to Earth and its area inside the decent zone have created critical interest and hypothesis about supporting life potential. Anyway, recollecting that is significant. The legitimacy of an exoplanet is a muddled enigma, including different factors. Proxima B is delegated an exoplanet with a mass around 1.3 times that of Earth and makes some orbital memories of around 11 Earth days, implying that it finishes one circle around Proxima Centauri in that time. Anyway, things are not so clear as we might suspect. The way that the planet is Earth-like in size and circles a red midget doesn't ensure that it is an ideal duplicate of our reality and that we can all move there. The reasonableness of Proxima B is not set in stone by various elements, one of them being a planet's climate, which goes about as a defensive safeguard and plays a vital job in controlling temperature. Also, life generally speaking. Anyway, the particular design of Proxima B's climate is still indistinct, making it hard to authoritatively decide its validity. James Webb Space Telescope analysts are at the very front of exploring the secrets of distant universes like Proxima B. Their steady journey for information drives them to create imaginative techniques and instruments to concentrate on the environments of exoplanets with a definitive objective of uncovering indications of something happening underneath the surface. Past our close by planetary gathering, one such instrument that holds tremendous potential in this work is the James Webb Space Telescope JWST. It is prepared to upset how we might interpret exoplanetary environments. The JWST addresses an extraordinary jump forward in space investigation, gloating excellent capacities to peer profound into the universe and unwind its secrets, outfitted with cutting-edge instrumentation and best-in-class innovation. This exceptional observatory is remarkably situated to handle some of the most squeezing inquiries in stargazing, counting the quest for livable universes and indications of extraterrestrial life. One of the essential objectives of the JWST is to zero in on the airs of exoplanets, with a particular accentuation on distinguishing biomarker atoms that could go about as indications of expected life. To achieve this objective, specialists have created refined observational procedures that bridle the telescope's unrivaled responsiveness, and goal 1. Such technique includes noticing travels, a peculiarity where an exoplanet passes before its host star is seen from Earth. During these trans, a little part of the star's light goes through the exoplanet's air prior to coming to our telescopes. By investigating the scent, light cosmologists can extricate important information about the arrangement and construction of the exoplanet's air. The JWST setup of instruments is explicitly intended to catch and break down the phantom characteristics of exoplanetary airs during travel spectroscopy. The investigation of breaking down light into its constituent frequencies lies at the heart of this cycle. By estimating the ingestion or discharge of explicit frequencies of light, specialists can identify the presence of key atoms like water, methane, carbon dioxide, and oxygen in the exoplanet's environment. Of specific interest are biomarker particles, which are substance compounds that might demonstrate the presence of life on a far-off world. Instances of potential biomarkers incorporate oxygen, ozone, and certain natural atoms like methane. Also, alkali. These particles have organic starting points on the planet and could act as evidence of life when never identified in the environment of an exoplanet. The JWST remarkable awareness and phantom goal empower researchers to identify, indeed, even follow measures of these biomarkers, giving pivotal bits of knowledge into the expected livability of far-off universes. Likewise, the telescope's huge gap and long noticing times permit for itemized perceptions of numerous travels, upgrading the measurable meaning of the discoveries and lessening vulnerabilities in the information. In the instance of Proxima B, the JWST holds colossal potential for opening the secrets of its climate and shedding light on its true capacity for holding on to life as the nearest known exoplanet to Earth. Proxima B presents a chance for point-by-point concentrate on utilizing the JWST's strong capacities by analyzing the light that goes through Proxima B's climate during travels. Analysts desire to reveal pieces of information about its compound organization, temperature, structure, and climatic conditions. Specifically, they will be searching for marks of key particles that could demonstrate the presence of life, like water, fume, carbon dioxide, and potentially oxygen. The JWST capacity to concentrate on the climates of far-off exoplanets addresses a huge step forward in our mission to comprehend the pervasiveness and variety of life in the universe. By outfitting the telescope's unequaled abilities, researchers are ready to make momentous disclosures that could change how we might interpret astrobiology. What's more, the quest for extraterrestrial insight, as well as zeroing in on the climates of exoplanets, the JWST will likewise assume an essential part in progressing how we might interpret the more extensive enormous scene. Its perceptions will shed light on an extensive variety of astrophysical peculiarities, from the development of stars, also systems, to the development of planetary frameworks. The James Webb Space Telescope addresses an exceptional apparatus for concentrating on the climates of exoplanets and looking for indications of life past our nearby planet group. Another significant element impacting tenability is the presence of water. Despite the fact that Proxima B is inside the tenable zone, deciding if it has sufficient water to be thought of appropriate for life is vital. Water is an fundamental piece of the riddle, and researchers are searching for indications of fluid water in the world's surface, whether as seas, lakes, or streams. These hints could be critical to surveying the chance of livability on Proxima B. The presence of water in various states like ice, Or then again, fume is additionally considered as water. Accessibility is fundamental for maintaining organic cycles and is viewed as a key mark of tenability. The presence of Proxima B brings up issues about its air. Specialists will additionally need to look at factors like temperature, pressure, and geographical movement on Prox B to evaluate whether the planet is inside a reasonable reach for life to flourish. Outrageous circumstances, like singing intensity or freezing cold, can make endurance. Testing strength is additionally basic. Volcanic ejections or seismic action could disturb livability, despite the fact that soundness is a great sign. Proxima B is accepted to be in a telelocked state, meaning one side of the planet remains everlastingly in obscurity, while the contrary side is dependably enlightened by the star. The star contrast between the enlightened and dull sides could make temperature varieties and elements that could influence the planet's livability. These are only a couple of perspectives that scientists are thinking about in the quest for livable planets. Scientists are exploring the substance creation of Proxima B to inspect the presence of natural mixtures like amino acids and different atoms fundamental for life. They are additionally breaking down whether the planet gets sufficient energy from the star or different sources to fuel natural processes and permit organic entities to develop, imitate, and flourish anyway. Notwithstanding all these examinations, the inquiry emerges as to whether Proxima B really has all the vital fixings to be thought of as a livable planet. Is there concrete proof for this? The revelation of Proxima B in 2016 was a surprising accomplishment. Cosmologists utilized the high-accuracy spiral speed planet searcher HARPS instrument to distinguish the unobtrusive gravitational draw of an exoplanet around Proxima Centauri, our nearest adjoining star. This high-precision spectrograph working at the Lila Observatory in Chile has been instrumental in the revelation of a few exoplanets, including Proxima B. The HARPS instrument works utilizing the spiral speed strategy, otherwise called Doppler spectroscopy. Its capacity is to distinguish exoplanets by estimating the inconspicuous changes in the star range brought about by the gravitational pull of a circling planet. These developments